Okay, good afternoon. Welcome to the TDAG meeting today. The Trees and Design Action Group, TDAG, is a network and a forum that brings people and organisations together to support the role of urban trees through better collaboration in planning, design, construction and management, and the maintenance of our urban places. Evidence-based information and cross-sector working is really important to us, hence the discussion forums that we hold every couple of months. And we would like to thank our partners for the presentation today, which is the Arb Association and IEMA. So my name is Emma Ferranti. I work at the University of Birmingham, and I co-organised this event with Sue James, who is all things TDAG, and also Jasmine Williamson. So I'd now like to hand over to Tony Kirkman, who is the former head of the Arboretum Gardens and Horticultural Services at the Royal Botanic Gardens, Kew, and Vice President of the Arb Association and a TDAG patron. So we're really lucky to have him here today. Tony, over to you.
Thank you, Emma, and good afternoon and welcome everyone to this Trees Design Action Group seminar on a glorious winter's afternoon with the wet temperatures starting to drop and the climate being where it should be. Understanding the value and fragility of soil. Let's go back to when we were at college, when we were all studying to be horticulturalists, foresters, arboriculturists. Why were we all frightened of soil science when we were studying? You know, I remember the nitrogen cycle, the carbon cycle, pH, NPK, etc. We tended to learn and do all that was necessary when it came to soil science to become qualified, and then we all put our heads in the sand or soil when it came to practicing good soil science on the ground. The Great Storm of 1987 was a real turning point for me and totally changed how I viewed mature and newly planted trees, and completely changing how I manage trees in the Arboretum at Kew. Seeing root plates upended in arboretum, woodlands and urban situations, and then wondering how they survived, how they managed to survive in the shallowest, depleted, compacted, and starved soil that clung to the roots. And that was a game changer, I believe, for many of us. Our soils, along with water, are one of the most valuable resources, but sadly, we have allowed our soils to be depleted, not just in our agricultural practices, but more generally, including in our towns and cities. And if we want urban trees to grow, then we must provide a healthy growing medium within the best tree rooting environments that we can create. And section 314 of Trees in Hard Landscapes dispels the topsoil myth and emphasizes the importance of using existing soil where fit for purpose, as opposed to the environmental harm of importing fresh, non-native soil. Soil is also a frontline contributor to carbon sequestration and mitigating climate change, and we give it the respect that it deserves and needs. During this seminar, we'll hear 4 eminent experts in their field explaining why caring for our soil is so vital to us and our trees. So our first speaker is Aileen Baird, a PhD candidate in fungal ecology. One of Aileen's recent pieces of work in January was Can't See the Forest for the Trees, the importance of fungi in the context of UK tree planting. Aileen's presentation this afternoon is Fungi, the Missing Link in Tree Planting Schemes. Over to you, Aileen.
Hello, everybody. I'm just going to get my screen shared so that you can see my presentation. So there we go. So yeah, as Tony said, so I'm going to be talking about this piece of work that was published earlier on this year, talking about the importance of fungi in tree planting schemes. And so this is something that I worked on as part of my PhD. And so the concept of this work started with the tree action plan. And so this was something that was, well, the England Trees Action Plan for, as I've put here, for 2021 to 24, published, I think about a year ago now, maybe a little bit over that. And it's looking at how we want to manage woodlands and increase woodland cover in England and in the UK more widely. And it had in it some very ambitious targets, so particularly for increasing woodland cover. So as I've put here, increasing the UK woodland cover from current about 13% to 17 to 20% by 2050. In terms of England, that's about 10% to 12%. So it's quite Scotland dominated in terms of this increase, but still a very dramatic increase in our woodland cover. And this is a very ambitious target. So we're talking about 30,000 hectares of woodland creation per year, and that's increasing. And the government spending looking at £500 million of the Nature Climate Fund being spent on trees and woodlands. And so very ambitious targets and very dramatic changes potentially in how our treescapes and woodlands look across England and the wider UK landscape. And so when I was reading this with my kind of mycologist's hat on, I was looking for any mentions of fungi and how they relate to this plan. And I was kind of shocked to find that it doesn't mention fungi at all anywhere. There are no mentions of fungi at all in the entire document, which is almost 40 pages. And I thought this was a real missing part of what is a key part of our woodlands. And so that's kind of how the concept of this paper came about, is thinking about how fungi are so critically important in woodlands and how really I think they should be included in future tree action plans. And so I'm going to talk a little bit now about why fungi are actually so important for woodlands and woodland creation. So the one thing that is mentioned a bit in the tree action plan is diseases. So in the action plan, they're talking about the context of pests and diseases. They don't specifically mention fungi, but it kind of falls under that umbrella. And so a lot of people are within the kind of woodlands, trees kind of industry are more aware of fungi in terms of diseases. So things like ash dieback is very much in the forefront of people's minds. It's obviously a massive threat to ash trees, and it's going to be a real, well, it already is a real financial risk, and also just in terms of when you're designing new woodlands, things like that, but also lots of other fungal diseases, things like obviously previously Dutch elm disease, and there are many future threats that are kind of just starting to come to the fore now. The other thing to kind of be aware of is that obviously climate change is then affecting what potential diseases we could have. So we've got increased stresses, increased risk of droughts, flooding, that puts our trees under more stress, so they're more susceptible to diseases, migration of pathogens to new areas. So diseases that wouldn't have previously been able to survive in certain areas, these areas now become warmer so they can. And then new threats, we've got ever increasing global trade, and that does increase the risk of diseases being spread, perhaps they wouldn't have been before. So another reason why fungi are really important within woodlands and trees is the fungal effects on human health as well as our tree health. So fungi release millions of spores, and these fungal spores can have similar effects to plant pollen. So when we're thinking about a lot of things that you get with plant pollen, so you get hay fever, a lot of people with asthma get worse symptoms, you get the same things with fungal spores, but quite often they're not really considered. We just think about pollen. And if we've got really increasing tree cover, so we've got vastly more numbers of trees, we're obviously expecting there to be more pollen, but we'd also expect there to be more fungi and more fungal spores, and this can have a knock-on effect. The fungal spore season, the big peaks, are often at different times of year than you get pollen peaks, and so for people that do suffer from hay fever or allergic reactions to spores, if they've got a big peak in the summer and then another big peak in the autumn with fungal spores, that can be really quite debilitating for people with those sort of symptoms. And climate change may also affect this as the fungal season changes. Now, one of the biggest things that we're thinking about with fungi and woodlands is carbon and nutrient cycling. And without fungi, the carbon and nutrient cycling in woodlands would just not function at all. They're completely vital to the system. So we're thinking about mycorrhizal fungi. So they're symbiotic with our trees. They're directly interface with the roots, which you can really nicely see in this picture here, where you've got your tree roots, and then you've got a much wider network of the mycelium around that. And so these fungi are receiving sugars and storing the sugars as the mycelium from the trees, and then in return they're giving nutrients back to the trees, and so it's this symbiotic relationship, and that's a massive carbon store. So up to 20% of the NPP in woodlands can be in fungi, And so it's a huge carbon store. And so it's something that's really vital if we're thinking about planting woodlands as carbon stores. The fungi are a vital part of that. And on the flip side, we also have fungi that are doing a lot of carbon release. So decomposition, breaking down the dead materials, so roots, leaves, that sort of thing, that's releasing carbon. And so the balance between this carbon storage and carbon release by fungi is really important. And one of the things that we don't understand completely yet is what that balance will look like as it changes with climate change, and we get higher temperatures, different fungi, different tree proportions, different types of mycorrhizae, how that might look and what that balance looks like going forward, and whether we have a net carbon storage by fungi or whether it ends up being carbon release by fungi. So I already said about climate change affecting fungal diseases, but climate change is affecting almost all fungi in different ways. So the fruiting season for fungi, so when they're actually producing mushrooms, has been shown to be extending. So it's starting earlier in the autumn and it's ending later. And lots of species are having an additional fruiting season in spring as well. So they're fruiting twice per year, whereas before they would only be fruiting once per year. Host ranges of fungi are changing. So over here, I've got a picture of wood ears. They're quite a common fungi. They used to only be found on elder, and that was their only substrate or their only host. And now they're found on over 16 tree species. And also we have some species that couldn't grow in the UK before, and now they can. So things like truffles, various species of truffles, didn't used to be able to grow in the UK because it was too cold, and now they can. And so climate change is really affecting fungi, and that's something that should be considered when we're thinking about how climate change is affecting our woodlands as well. And a final factor is that as well as fungi potentially being beneficial for woodland planting, they can be damaging in terms of the diseases. There are also fungi that are threatened by tree planting. So in the UK, we have a real stronghold for grassland fungi. So this is a wax cap here. There's a kind of grassland fungi assemblage with various different types of fungi that are associated with this type of habitat. But it's a really rare type of habitat internationally, and the UK is one of the most important countries for these rare fungi. And the grasslands that they're found in are these very low nutrient grasslands, often grazed, sheep grazed, that sort of thing. And they're very threatened by tree planting because it's quite typically areas of land that are potentially more unproductive that are then put forward for tree planting. And so these types of fungi are at risk from tree planting. And so this is where we come to this figure that I have in the paper, where we've kind of identified all of these reasons why fungi are important in tree planting. And so it might be that they're important because we need to think about the disease burden, and so the fungi are causing risk to trees. It might be that the fungi are beneficial and we want to maximize that. It may be that tree planting is actually threatening some types of fungi. And so in one way or another, fungi are related to tree planting and woodland creation in some way. And so we then started thinking about, okay, what can we actually do about this? What are some reasonable guidelines or approaches that people who are looking to create new woodlands could take and could put in the kind of existing plans that they have for creating woodlands that means fungi are considered? So the first one was thinking about monitoring fungal diseases. And this is something that is already done at a fairly reasonable scale. So things like the UK Plant Health Risk Register, which is growing all the time. I'm sure since I put the numbers in the paper in early 2022, it's grown massively. And things like Observatory as well, citizen science project looking at helping people to spot pest and disease threats and report findings. Things like this are really important because they help us monitor the spread of diseases, fungi and others across UK treescapes. So that's one thing that is already being done, but the scale of that, the more we can increase the scale, the better, really. Another thing that, again, is mostly being implemented is thinking about planting well-designed schemes. So one of the big things that we're thinking about with planting new woodlands is carbon storage. And to have good carbon storage, you need the right fungi and healthy soils. And the main thing you can do there that's promoting it is, rather than trying to start introducing novel fungi into the system, it's thinking about whether trees are suited to the habitat that they're going to be in. So we're not planting trees on peat soils. We're thinking about trees that are suited to the habitats and the climatic factors in the landscape. They're more likely then to have fungi in the soils there that are going to benefit those trees. We're avoiding monocultures. That's higher disease risk. And then we're also protecting existing habitats of value. So we're avoiding things like wax-capped grasslands, avoiding things like heathlands and other habitats that have innate value in their own right and wouldn't be suited to tree planting. In terms of the human health perspective, from this side, we're thinking about implementing widespread spore forecasting. And so that's something is very common in the summer, that once you have your normal weather forecast, you see there's a pollen forecast on that. And so one thing that could be added to that is a spore forecast. It means that people who are at risk could manage their symptoms, potentially take any medications that they might need, and it would help to minimize and mitigate the risk of this to people, with also maximizing the benefits that we get from woodland planting. And then we're thinking about protecting the species of fungi that we already have. So many people will be already aware of the Red List, and this is an international thing of listing species of all types that are at risk from extinction at different levels depending on the risk that they're at. And although we have some Red Lists for some groups of organisms in the UK, we don't have a Red List for fungi. It's not nationally recognised. And so this would be something that would mean that rare fungi are protected, and it means that they can be taken account of more carefully, and it means that people are more aware of fungi that are at risk if there's a clear and transparent way of recording this and making data available so that people can find the information that they need. And finally, assessing sites for fungi, which I think is one of the most important things. And although I've put a couple of slightly tongue-in-cheek photos here of me sitting on the ground looking for fungi, assessing sites is really important. Data is vital, and it's one of the things that very few sites, for example, before a woodland creation project, would have the site assessed for fungi. And so I think having a number of case studies where we can do fungal fruit body sampling, we can do soil DNA studies before tree planting, during the process, and a number of years down the line will be a really vital piece of data. It will not only enable us to see how the fungal species change, and so we're just thinking about protecting fungi that are there, but it may also enable us to improve systems. So say if we're planting in a really depleted soil, it might mean that down the line we could start thinking about introducing fungal species that might benefit the trees, but until we know what species are there in the first place and which species are colonizing the trees at different parts of the process, we don't know what fungi we need to introduce. So it's all about data collection and filling in those gaps in our knowledge. And so I think of all of the suggestions, this is the one that I think is the most powerful and fills in the sort of the biggest gap that we have in our knowledge at the moment, is data collection. And so with that, I will leave you on this slide here. So this is the figure from the paper. I think Emma said the slides are going to be on the website. So there's a link here to the paper itself. And then we also had an article, if you want a shorter read, about the paper in the conversation, which the link is there. So thank you, everybody.
Thank you, Aileen. Spot on with the timing. Thank you. And a really interesting paper, and something I think that we take for granted, and we need to have it higher on our agenda. Are there any burning questions for Aileen? Just going through the meeting chat. I think Sue James has said, so we need a land use strategy that considers multiple issues in deciding where to plant trees. And I think that's going to be quite critical, actually, so that we're not planting trees willy-nilly here and there just for the sake of hitting targets and putting the wrong tree in the wrong place for the wrong reason. So, you know, that's a very interesting comment. Good. if there are no other burning questions, I'm sure there will be more when we come to the discussion at the end of our 4 speakers. So I'm going to introduce our second speaker, who is well known to most of us. Glyn Percival is a senior arboricultural researcher at Bartlett Tree Research and Diagnostic Laboratory at the University of Reading. Soil is a living, breathing organism. Glyn's talk is to inform everyone of the current health status of UK urban soils and how you can evaluate the health of your soil and what you can do to improve your soil. His title of his presentation is Urban Trees Creating Biologically Vibrant Soil for Long-Term Sustainability. Lots of words there, Glyn, so over to you. Thank you.
Okay, thanks, Tony. Hopefully everyone should see this. Okay, yes, again, I'd just like to thank TDAG for inviting me, and again, to talk about this concept of creating biologically vibrant soils. Now, as part of my job, I do get to travel a lot around the UK, and these are just some of the places I've been to this year. And what I like to do is when I'm kind of going around the different kind of urban landscapes, the towns, the trees, you know, that are growing in cities, etc., is look at the tree health, and more importantly, actually look at the soil conditions. So, for example, when I kind of see this, which is rather sadly time and time again, I always just basically take a soil sample, work out what the trees were actually growing in. So over the probably about the past 8 to 10 years, I've literally got over a couple of thousand soil samples, so I can start to build up this picture. Now, obviously, taking a soil sample should be a very straightforward process. Should be, but this is kind of the situations we find our trees growing in. And I also find it quite amusing when people actually pay me to go out to look at trees and they say, why have my birch trees died? And I'm like, it's a tough one. And just to give you an example, this is a planting scheme, and it was done in January 2019, and they planted 220 trees, and about 6 months later, they had an 87% death rate, which again, that's pretty impressive. And then we did a few pit excavations, and this is, and I use the term soil very loosely here, this is what the trees were growing in. So no great surprises that we start to see these high death rates. So we do know that really soil quality is the key to tree survival. As you know, Tony said, you know, soils are a living, breathing organism, and we have to treat them as such. And again, I see this time after time after time, and really the soils aren't fit for purpose, particularly in these very hardcore urban landscapes. Now, really, in terms of urban soils, there are 3 main problems that I come across time and time and time again. And the first is compaction. Soil compaction probably kills more urban trees than any other type of environmental stress. It's huge. And it's a shame, because there are some very good techniques to alleviate soil compaction. The latest one is the Vogue. There's air spading, there's vertical mulching, radial trenching. And I'm really not trying to be facetious in any way, shape, or form, but if you really want to know if your soil is compact, then it really just comes down to a quick tip. If you don't like digging it, roots don't like growing in it. So if you're trying to turn the soil over and you're using pickaxes and crowbars, I mean, the trees really aren't going to survive. And you know, despite all the work that's going into like species site selection, you know, with all due respect, some of our urban soils are so inhospitable. Doesn't matter what species you plant, they are not really going to survive. The other big problem I find is the pH, inappropriate pH. And this is just one of many examples where you can see the pH optimum for 95% of British trees is between 6.2 and 6.5. And you can see here is the pH is out of sync, but look at the soil nutrients, they're actually okay. And look at the organic matter, it's off the charts. And the reason why is that the nutrients are there, but the soil is so compact, and it links into my final problem, there is no biological activity. So you've got to alleviate the soil compaction, and you can easily determine pH very quickly and simply using these probes or these tester kits. It's really not that expensive, and it's quite a quick fix. So it's soil compaction, pH, and biological activity. So how do you measure biological activity in soils? And there are two quick tests you can use. One is what I call a worm count, which I've spoken about many times before. I mean, really, worms are an excellent indicator of soil fertility and biological activity. So you should have at least 2 worms in any spadeful of soils. But again, I appreciate most landscape soils, you know, these the planting pits are not going to have worms in there. So this is another simple test you may not be aware of. This is used extensively as a measure of biological activity by soil scientists, and it's what we call the cotton strip test. And you can buy this unbleached cotton strips. You can buy them from Amazon. And I mean, it's like £3 for a couple of square meters. It's really cheap. I mean, these tests work out at maybe 15, 20 pence per test. And you bury the strip underground at 15, 30, 45 centimeters. And you, in essence, dig it up 3 weeks later and assess the percent composition. Again, a huge raft of research out there showing that. So that's kind of how you test for biological activity. There's other tests. You could buy one that measures soil respiration, an infrared gas analyzer, but they're about £50,000, or use the cotton strip test. It's about 20 pence. So how do we improve the biological activity? The real key point is you have to add organic matter. Organic, it's living, it's compost, it's biochar, it's a biostimulant, it's a mycorrhiza, it's a seaweed extract. Because it's living, it's got organisms, bacteria, fungi, biological activity. But the answer is, which one? There's just so many. You know, so the key to improving this biological activity, and as I say, there's such a huge diversity. Anyway, to answer that question, this is a wonderful trial site I have. This is at Stockley Park. It's next to Heathrow. It's a huge industrial business park. The people who run it are absolutely great. They give me free access. I had 120 planting pits with the same species, all pretty much of the same size. It was Sorbus area, and they were literally like, just knock yourself out. So I thought, fantastic. We can really start to do some good research here. So again, took out some soil cores, sent away 120 soil analysis, and really what we came back with, a heavy clay, they had low organic matter, 1.2%. The norm needs to be between 3 to 5. Limited biological activity. There were worms in there, like maybe 1 worm. And the CST is the cotton strip test of say, it came in at 22% decomposition. So again, it's what we classified as poor. So it's not horrendous, but it's certainly not good either. It gives us something to play around with. So we set up a huge planting trial. We looked at a whole range of different products, some of the latest stuff on the market, this terracotta, which is a water holding gel, and one of these kind of like biochar and slow release fertilizer combinations. We looked at charcoal as well as biochar, because biochar is incredibly expensive. Charcoal is about a third the price. We looked at different types of commercial biochar. We looked at perlite, etc., etc. And because it was so big, we could actually assess the importance of these products with and without a wood chip mulch. And when we looked at the data, we primarily wanted to look at root growth, hence the sieves. So I could sieve, when I say I could, my research technicians could kind of sieve all the soil from the roots, and different sieve gradients gave us different kind of root fractions. And then you can see where we then, once we've got the root dry weights, we can then soak them in different solutions to do a lot of staining for the mycorrhizae. And so this just gives you an idea where we can use different staining techniques to stain for like mycorrhizal hyphae, which is towards the left, and quantify it. And then the one on the right is the actual, the arbuscular mycorrhizal stacking, the actual living organism itself. So obviously I'm not, because I don't really have the time to present you with reams and reams and reams of data. So what I want to do is just kind of show you some interesting trends we're picking up on. So first of all, we can see that there is a difference in the treatments. You look at the two end ones, and obviously two in the middle. So it's a 3-year trial. I've just got the data. What I'm presenting is the end of year 2. So I want one more year to go. Again, once you kind of get up close, you know, you start to see some quite nice differences emerging. So we know something's happening below ground. So the key is, what is happening below ground? Well, first of all, when we got the root dry weights, we started to see some data which was a little bit puzzling, in that we were finding that we were getting more root growth in the controls compared to, for example, a WCM is a wood chip mulch, or even a biochar, or a biochar and wood chip mulch combined. So that was a little bit, whoa, okay, wasn't expecting that. But then when we look at the mycorrhizal associations, we're kind of seeing an inverse relationship, in that, yes, we are getting less root growth, but what we're seeing is more mycorrhizal, or a denser, more vibrant mycorrhizal association, which is kind of acting maybe as a way of scavenging all those nutrients. So why produce roots, which is an energy consuming process, when you kind of less is more, as it were, less root growth, but just as much nutrients and improvements in tree growth, etc., by a greater mycorrhizal association. So as I say, I really don't have time to go through all the results. What we are finding is the one that is giving us the best results so far is all the lessons we're learning, is that we alleviate compaction, we get the pH right, and out of all the treatments, the one we're finding is biochar, compost, any good general tree compost, and an organic fertilizer. I put in there chicken pellets, I mean blood fish, bone meal. And the only other treatment I haven't had time to talk about is what we're dealing with these planting pits. If I have a lot of beech trees and I go to, say, Burnham Beeches and actually get some native soil and add that really has also a big impact. So if you're planting oaks into an urban landscape and you can get soil from a well-established oak tree, it really has a positive. And again, but I asterisked it because I mentioned it to someone, and I kind of upset them a little bit because they said it was a biosecurity risk. I don't know. I don't know. We just seem to live in a society, no matter what you say to someone, you upset them. So anyway, but that's kind of where we are at the moment. We're finding this biochar, compost, organic fertilizer, and a little bit of native soil. This is just a photograph I took recently in Oxford, and it just shows you a wonderfully large trees in what appears to be obviously some quite small planting pits. So that in a nutshell is my talk done. Okay, thank you very much.
Thank you, Glyn. Interesting as always with, and it's really good to, keep up to date with all the different research and results, controls, etc. that you're doing at the labs, and it always gets the brain going, and trying to marry your research with what we're all doing as well. Quite a few interesting comments coming through on the chat line, so keep them coming through. Daisy thinks a cotton strip test should be called the underpants test. So if you've any old underpants, cotton ones preferably, we could try those in a planting pit. So how quickly
I'm sure there's a research paper in there, Tony.
But really interesting. The three key things: compaction, which from 1987 was a big thing for me. Probably one of the biggest killers of trees for sure. And I love the saying that you have there: if you don't like digging it, then a tree doesn't like growing in it. That's a good way of thinking about that. I mentioned pH at the beginning. We all, one of the first things we learned when we were studying horticulture, arboriculture, forestry, soil ecology, etc., was pH and what that meant, and how serious inappropriate pH is to the survival of trees. And that biological activity and that easy test, 2 worms in a spade. You had quite a small spade there, I've got to say, Glyn, in your photograph. So, but these are easy things that we should all be doing, and keeping an eye on before, and planning before tree planting. So thank you very much for a very interesting talk. I think I'm going to crack on with.
Tony, I just noticed there is a hand up.
Is there? Oh yeah, Conten. If you'd like to ask your question, Conten, you might have to.
Hello. Sorry, my name's
right.
Emma. Emma Content. Yeah, thanks, Glyn. That was really interesting. I'm a landscape architect. I was just wanted to pick up on the point about native soil. Maybe it's not a quick, easy answer, but where I'm interested in sort of the contribution of that in the mix that you suggested with all the other factors, and wondering if you get a feel for how much of a difference you think that actually makes, and in terms of trying to implement that. Seems like it. I mean, it could potentially be difficult to control that. People trying to access or gather soil from specific locations that might impact existing stands of trees. Or
I think the reasoning behind it was that there's a lot of these mycorrhizal products you can buy commercially, and I just kind of felt, well, they're incredibly expensive, and when you look at these commercial mycorrhizae, they're just like, basically they're endo and ecto, and they just throw everything in there, and there's so much scientific research showing they really don't work. And we just thought, well, maybe if we just took, I'm not saying we go in and plunder our native woodlands. You really don't need much. I was adding it at something like probably less than 1% by volume. It was just that little bit of kind of thinking, well, these trees are established. I didn't really have time to put any data up because, 12, 15 minutes. So I didn't put the percentage ratios, but it was really just saying to people, if you can, I'm not saying it's essential. The real key one is getting that you know, as we say, the organic matter in the, you know, whether it's chicken pellets or blood, fish and bone meal, it's some organic matter, getting some compost. It was just that little bit rather than spending, and these commercial products are very expensive. So it was just, you know, if you're planting cherry and there's maybe a mature cherry tree going close by, a little bit of soil from there is obviously going to have a lot of the native kind of bacteria, mycorrhizae, and to me it's a cheaper, kind of more logical and also more efficient system than using these commercial products. That's all.
So just like seeding it
and
with a little...
as well, and I mean, these commercial products you can buy, and I could be wrong here, but you know, I don't know where their provenance is. I don't know if they're from commercial mycorrhizae you buy. Are they mycorrhizae derived from UK mycorrhizae, or are they from like other countries? I don't know. I mean, things cross my mind a lot. That's all. So
no, it raises a lot of interesting kind of further research, I guess. But thank you. That's great.
Okay, thanks.
Thank you, Emma. Thank you, Glyn, for fielding that question. So our third speaker is Birgit. Now, forgive me, Birgit, if I pronounce this wrong. Honsk, who is a senior project lead with Cornwall Council. Birgit's going to cover soil management through the planning and construction stages of development projects. So thank you, Birgit. We'll look forward to your presentation.
Thank you, Tony. Yes, so it's Birgit Honsch. I'm senior project lead at Cornwall Council. I'm also a trained landscape architect. So I'm currently the chair of Landscape Institute Southwest branch. So I've had the privilege at my work to be able to get involved in soils through my work, and I'll just be talking today a little bit about our journey on that route. We are in early stages, but yeah, it's very interesting, and there has been quite a few thought processes that have been started through our getting involved from the Cornwall Council side. So I actually work in Cornwall Council in the planning and housing service as a client, in a client role, so on the garden villages. So that means I have got a fair bit of influence over what might be happening as a strategic client, and it's a very interesting role to be in. Yes, so I'll be telling you a little bit about our Cornwall Council Soils and Planning and Construction journey. We've just, on this last Monday on the 5th, it was World Soil Day. Sorry, I'm just gonna have to close a couple of captions here. I can't see what my screen. So it was World Soil Day this Monday, Monday gone. And Cornwall Council actually hosted the Southwest regional launch of the Soils and Planning and Construction report there in a face-to-face event, which was very successful. There were over 70 people there, good range of speakers. So really just to try and continue on our journey of raising awareness. And really the World Soil Day this year was really also focused on food. It does actually mention the soil management, increasing soil awareness, and improving soil health. And I think there's a really direct link there to our construction development and construction sectors. So one of the key things that also sort of came out of the report is really soils are a resource, not a waste, but the mindset at the moment in a lot of the industry is that it is a waste product, and the product that is in the way rather than something that is a resource. So it's then about how can we change that mindset. So Cornwall Council's journey then of why we actually got involved with this. Cornwall Council is a member of the Soil Task Force. At my last slide, I've got a link to the website. And that came about really through our involvement with the Garden Communities Programme from the government and the TCPA, who have a new communities group. So in Cornwall, we have got 2 garden villages, which is the one that's on the screen, that's Langas Garden Village. We also got West Carclays Garden Village. So in the Langas Garden Village on the screen, being one that is just starting to come forward, being a scheme that is on sloping ground, essentially going to form an urban extension to Truro and on greenfield land. So the issue of soil here is actually really important because of the sloping side, because it's greenfield, because we as a local authority want to really make a point that we are looking at this sustainably, and we do want to work within the sustainability credentials that the new garden village community requires. So the contacts then with other communities, including Bailric, was very interesting, and the teams there were struggling with similar issues, with similar problems, and then the idea was formed, really, we should all join together and see whether we can do something. And Lancaster University was at the time looking for partners to support a project they were trying to get off the ground to look at the planning and construction sectors and soils. So that's how the Soils Task Force came about, and how Cornwall Council's involvement then emerged from that. So this is then a picture from enabling works on that scheme up here. So, and that was before we started on our journey with soils, and it shows a very traditional approach really to your normal construction site. So at the moment, normal sequence is a designer draws a plan, they detail some levels, highly likely without detailed consideration of soil levels and what the levels that are on the plan actually will mean for topsoil stripping, etc. So it goes to construction, and the first thing they will do is strip all the topsoils, do a lot of digging, create their formation levels, and by that time you've probably lost most of your topsoil resource, impacted it, and also you've created a lot of cut, potentially fills. It depends how well the design was balanced with the cut and fill balance. So, and it's then a question really of how can we change, how can we influence that process to make it more sustainable? I mean, a construction site will always be a construction site. It will always be muddy. There will always be soil movements and earthworks. But where in the process does at the moment, where does it fall down at the moment? And actually that it's not thought about early on, that therefore then it doesn't translate into what's happening off the ground. So it is less sustainable than what it could be. And I just maybe link back to a couple of the presentations we just had. I mean, if you look like this, the soil that's been stripped and dug out, you're losing existing fungi populations that would be there. You probably, the topsoil might have been stored a very long time, or it might have even been taken off site and then new topsoil imported. So you're losing all that existing ecosystem that's in the soil. And then you're also creating a lot of compaction. And a lot of times that isn't not necessarily alleviated properly. And yeah, I guess the banks under there would be engineered banks. So they have got properties that aren't necessarily conducive to tree roots, for example, if they're engineered embankments. So it is, how would you look at this? A constructionist, traditional construction approach, where can you have the hooks to start influencing how we think about this? Obviously acknowledging it always will have to be construction if we want to build something new. So and then I'll just, so yeah, from our journey brought us to this point. We got involved with the task force, we contributed to the report and the research. And so I think TDAG was very helpfully helping with that, and through some interviews as well. So, and then the report then started looking at why is that actually important? And that for us as Cornwall Council was quite eye-opening as well, because there's a lot of facts and figures that we didn't know. So everyone involved was quite staggered by some of these numbers that started to come out of this. So if you look at the 29.5 or nearly 30 million, as it says in the report, tons of soil from construction sites that go to landfill every year, only 0.6 of this is due to hazardous stuff. So the rest is going to landfill, and it's a resource that has developed over millions of years, if you want. And I mean, this figure is not split out by topsoil and subsoil. So not all of this is topsoil, but a fair percentage of it is likely to be topsoil. So there is an economic implication to this. There's a natural resource implication. And if you compare this to the erosion, so, I mean, people always say, oh, agricultural erosion is really bad, but actually it's only in the UK, 1/10 of what actually goes to landfill from construction sites. And considering that construction sites are actually taking up a much smaller space than all the agriculture, that is a staggering figure. So, and soil erosion on construction site itself can be 100 times greater than on agricultural land. So there is a real issue there, again, that goes into water pollution, etc., and everything else. Compaction can reduce all the, as we know, the uptake of water, can also affect trees if the tree protection zones aren't in place properly. So, and another big fact that sort of led us to start looking at this more closely is also that soil is actually the second largest carbon store on Earth. So after the water, it is the soil. And the main carbon is stored in the top layers where all the organic matter is. There is some carbon in the subsoil as well, and it's a science in itself, which I don't pretend to be an expert on. But say if you have a construction site and you strip all your topsoil to start with, because that's what we always do, you've already really negatively affected your carbon balance. However, the carbon balance of soils is not really taking account in any of the current carbon counting mechanisms. And if you strip it, you wouldn't necessarily lose all of your carbon, but it does affect the decomposition processes, etc., and all of that. But if you, for example, take all your topsoil off site, you've removed a load of carbon from your site as well, and possibly releasing it into the atmosphere. So, I mean, there's more figures in the report. I've put down there, if you, I have got a link in the end of the presentation as well, where to get the report from. There's sources in the report if you want to read more about that. But yes, it is staggering if you start looking at this from that aspect, and then you start seeing that the planning and construction could make a huge difference in that sense, even if it is in terms of land take much less than agriculture. So the report, there's the front cover there on the right. It does provide an overview of the current policy and guidance. There is a really useful table in there, which outlines what's out there at the moment. And I think one of the things that we found working on this is that whilst there is a lot of guidance, a lot of it is partially focused on waste. There is some sustainable stuff, but the guidance is there, but the actual application, how it's applied to the practice and how it makes a difference is very limited. And then there's reports that are also very long and very technical in places. So the guidance that is in our report is actually quite a snappy, short report with quite detailed guidance for various disciplines. And the three key barriers that the researchers found by Lancaster University, speaking to a wide range of industry representatives, that the first big one is soil is not understood and not valued. And in my mind, this is an absolute key realization, even if we might know this in our background, but in day-to-day work, are we actually aware of soils? Are we, when trees, we're thinking about root protection areas, and this has come more to the forefront. It's still a struggle, but it's actually now sinking into people's minds. Soil really isn't, and soil is something that, yeah, might be looked at as cut and fill balance and earthworks plan, but not really as a resource and as a sustainable medium that needs to be protected and improved in its own right. There's also the lack of soil data availability. I mean, in a lot of times, the construction sector will, as part of a planning submission, you might have to submit an agricultural land classification assessment, but that's very different to an actual soil analysis. You might also have engineering assessment of soils, but does your soil survey include detailed mapping of topsoil depths, for example, carbon content in them, suitability for plant growth, and possibly even, is there any mycorrhizal activity in them that could be reused across your site? So the data availability as such is not there, and also what is actually being done on site in terms of surveying it, what currently is requested in the planning system is quite limited in terms of really informing sustainable soil management. So in our report, there's 2 appendices which outline a little bit what you might want to ask for if you ask for a soil survey as part of your project, for example, so you have the right data to work with. And then there's the time and space constraints as a key barrier as well. So, and this is something which is real, and it does pose a challenge to construction sites when all the machines come on site, and you do need to make things work, and you need to have compounds, you need to have whole roads, you need to get the levels to the right levels, etc. If you strip your topsoil, you need to store it somewhere. There is guidance on how high and wide and deep it has to be, how long it can be there. So it's actually quite a big logistical challenge. But equally, it's also a big cost for a developer to have to cart away a lot of soil. So thinking about this from the outset would make a viability difference and will probably help to deal with your time and space constraints. So I guess with a lot of you in the room today are professionals, maybe tree professionals, landscape architects, ecologists. So we can have an influence on our clients, I guess, try and work with them to realize some of that. So the report then sets out 8 guiding principles, and I come on to these on the next slide. And then there's also a few pages of specific actions for local authorities, clients and developers, design teams and contractors. So, and for me, this is really important, I think, as sort of a hook and something that you could use to talk to your clients about that subject and to say, look, we can make a difference here. And a lot of times it is also the link between the initial concept planning and then delivery where things might fall down. Sorry, I'll try and conclude my talk soon. That's the guiding principles that are on the right, on the left here. Some of it's basically things that are in people's mind when they're built, but are we actually thinking these through? Are we thinking where we want to be when this thing is delivered, what we are actually designing? And are we really thinking about this in the maximum useful way to generate the maximum benefits? So I've just highlighted here on the right to which stages these things might apply in your process. And so the first one is, in my mind, very important, and it goes across a lot of the construction stages of the inception from design to planning and to construction. So, and this is where really, I think, as professionals advising clients, as people surveying things, as people providing tree surveys, we need to engage, we need to collaborate, we need to look at site levels early on and not just sort of think about it briefly. For example, in a lot of times you get the residential development and the gardens that are being installed, they might have 200 mil of topsoil on rubble and compacted ground. So what if we thought about this from the outset and we designed our formation levels that we could actually put back, say, a 40, 50 centimeter topsoil layer that actually would enable someone to grow trees and successful vegetables, and so maybe even trees and shrubs successfully in their garden, and also make use of the existing soil that's on site without having to cart it away. But that would actually mean at design stage, you have to think about this and you have to have your formation levels lower. So therefore you have to design it that it works with the existing subsoils, because otherwise you just end up digging out all the subsoil to put topsoil back, which wouldn't make sense either. So it's that sort of, well, it's detailed thinking. And before now I've been accused, oh, it's too technical. We're not at that technical stage. But I think there are instances where you have to think about the technical implications, because otherwise you will not actually be able to make it work. So the engagement is important because, as we said, one of the key barriers is actually the lack of understanding and the lack of value. So the reuse and share soil is something that isn't widely done at the moment because it's quite tricky, and that's something we locally might want to explore. And I think there's an interest in Cornwall to have a look at that. But again, it's about collaborating, talking to other people. Permeability is a design issue that needs to be looked at design stage. Compaction and stockpiling and minimizing erosion, that's all construction stage related, but is there enough understanding out there? And then we also have to learn through training, and I hope today is a little step towards it. So shouting about it, what we've done, and giving people some tools. Very briefly, just the last slide. I know I'm sort of out of time now. So in Cornwall Council, we are at the start of our journey there. We've contributed a report. We have recognized there is an issue and we want to do something about it. Our Langa scheme was submitted with a high-level soil strategy, and we're now exploring how we could move this forward. So, and just by having contributed, by being aware of it now, we are hoping that in future as Cornwall Council, we can actually actively start incorporating soils into policy development and future local plans. Maybe have a closer look at soils during the planning stage, train some of the planning officers to look at this in more detail, use the guidance shared with our third parties, with our planning agents, etc. Look at our own site, see what we can do different, collect best practice, and then also raise the skills and make sure people are aware. Right, that's it for me for the moment. So there's just the link to the Soils Task Force where you can download the report. Thank you.
Thank you, Birgit. Excellent presentation, and one that I think is going to become more and more apparent as we go forward. Some very important facts about the carbon lost to landfill, 10 times greater than what's lost to erosion in the UK. Soil, obviously the second largest carbon store on Earth after the oceans. The question from Sue that came up in the chat was, how do we enforce better practice on construction sites, Birgit?
Well, I think you've got SEMS. SEMS are a standard accepted document and is, I guess, about making these SEMS maybe more focused on soils, for example, because they do cover a wider range, including, for example, ecology and everything, but soils could be a much more prominent subject in SEMS, for example. And then by having the SEMS, there's normally a clerk of works, so you would need to train your clerk of works. And also, I think the planning authorities, they need to start asking perhaps for more conditions relating to soils. I mean, for our Langa scheme, there is actually earthwork strategy conditions in there. And yeah, for local authorities, monitoring is always an issue. So whether people would want to consider including some monitoring functions in S106 agreements, for example, so there's actually some money that things can be monitored. But in my mind, sort of SEMS and clerk of work roles and an understanding, better understanding in the industry to the role of soils, that they are a resource, that they are valued, they are important, and they can actually help with your costs if you do it right.
Very good, thank you. And I suppose training, you said you mentioned the importance of training as well throughout the process, from planning right through to construction. Yeah, I think soils is one of these things where it's taken for granted, and it's in subject of that's how we've always done it. Why should we do it any different? So, and that's really quite difficult to overcome. But there is, and in that sense, there's also a link to, I guess, all the trees and the tree root protection areas, because where you have tree protection, you also have to protect your soils, and can that be sort of used more sort of collaboratively, maybe make it a bit bigger, and also areas maybe set aside for early planting that would protect soils, and then maybe bring the soil aspect of this more to the foreground, so that people can see in case studies, draw it out in case studies, so people can see how it was thought about. Good. Sue's just said, bring back the Clerk of Works. Gosh, that was a title, wasn't it? We've all forgotten about. Great, lovely. I've heard it a few times. We've got Clerk of Works around occasionally, but often they are more trained, well, they're trained to look at roads and curbs and tarmac, but they're not necessarily trained to look at landscape and soils. So it's, you know. Education. Thank you very much, Birgit. I'm sure there'll be more questions in our discussion period. So I'm going to go on to our final speaker this afternoon, who's Luke Engelbach of Studio Engelbach, which is an environmental design practice in Kent, specialises in eco-urbanism, a whole system approach to planning and design that addresses climate change, resource depletion, and flexibility as a response to making places for people. It was formed in 1996, and it's been involved in many projects that deal with the interface between urbanism, ecology, and environmental sustainability. Luke is going to tell us how to protect soils through ecologically guided project implementation. Thank you, Luke.
Sorry, unmuted. Hello. Yes, this is the title I was given, but I felt that I needed to put it in some context, because what we really do is planning in a whole system kind of a way. So, as Birgit said, yes, it was World Soils Day, and apparently an estimated 75% of Earth's land surface has been degraded, and this is equivalent to about 10% of the annual global gross product. So it's a lot. It's an expensive thing. Obviously a lot of that's to do with agricultural soils, but of course there's a big part to play in what we do in cities. How can I move this? Oh, there we are. So we know it's code red for humanity, and things are getting worse and hotting up, and this is making problems for soils in cities as well. We've got a few years to change things around, both in terms of trying to arrest climate change and to deal with biodiversity. And of course, soils play a big role in both of those things. We're one of the founding signatories of UK Landscape Architects Declare Climate and Biodiversity Emergencies. And of course, that's two sides of the same coin. There are 12 principles which are on the site, but a lot of it's just advocating faster change to resilient and regenerative design, adoption of a whole systems approach to landscape design, which includes things like mitigation, adaptation, to climate change, etc. But also sharing knowledge, is what your seminar is doing today. Just over a year ago, the United Nations Environment Programme produced this book called Making Peace with Nature, where it highlights not only the biodiversity and climate emergencies, but said there's a pollution emergency as well. So all of these things need to be addressed in how we design things. Cities are complex social ecological systems, and so we have to understand how systems work before we can start to try and make some interventions using leverage points to actually address it. It's interesting that as a kid, I was totally fascinated with the Apollo moon landings, and it's now 50 years since the last of the Apollo ones, but also just last week, we got the first rocket going back to the moon again. And of course, that was when we first saw Earth all by itself. And at that time, Barbara Wood and René Dubose wrote an informal report for the then United Nations General Secretary for the first United Nations Habitat Conference in 1972, concerned about limits to the amount of manipulation that we can exert on natural balances without causing a breakdown in the system. So here's a diagram just to show where we need to shift to in terms of trying to get that soil thinking right at the beginning of the design process. We're talking about living system design and going for regenerative design rather than just sustainable design, which is absolutely key. And there are different scales in which we can operate as designers, but they need to be rooted in fundamental natural processes. And the eco-urbanism I speak of actually spans all of these scales, which I think is important, because even if you're planning something, you need to be thinking how that might be happening when it gets to the site situation. Famously, Franklin D. Roosevelt, at the time just after the Great Dust Bowl, said, "A nation that destroys its soil destroys itself." And we are destroying soil at an amazingly fast rate. Tony Juniper points out the value of soil in terms of its benefits for raising food, fuel, fodder, fiber, fresh water, and carbon capture and storage. Urban soils, or urbanization, changes soil carbon pools and fluxes. And something that we need to address is how we minimize soil carbon emissions from urban soils by the way we manage them. And also the fact that soils respire as the temperature gets warmer and release more carbon dioxide into the atmosphere. So if you've got a hotter urban environment, you're likely to see higher carbon dioxide emissions from urban soils. And this gives a good reason to take measures to cool down the urban atmosphere or cool down the urban temperatures using tree planting and other types of planting. So it's really about how we manage our system as well as design it using nature-based solutions and natural systems. For example, it's quite interesting, a recent study from 2014 showed that the number of soil biomes, soil microbial biomes which exist in Central Park, for example, are many and equal the number that are found across the world in many ways. So we can link into that, and not much is known about it really. Soil peds and pores, we often seem to be buying ready-made soils which have all the ingredients which are on the list, and yet they miss one, which is actually the ingredient that actually forms a proper soil textured soil crumb structure from mycorrhiza, from root exudates and microbial excretions. That's important so that we can get soil and air and water down into the soil to the roots to really make things work. And it's something which has been ignored to a large degree with this huge industry in manufactured soils. So soil is also, as we said earlier, a hidden part of the climate cycle, which is key. I'm using 4 times more carbon than is in plant biomass. It's a huge amount, 2,500 gigatons, but that's mostly in peat and permafrost. There's less happening in the hotter regions, more in the cooler regions like us of the world, which is interesting. And soil microbial respiration releases a significant amount of carbon every year. So we need, because that's promoted by global heating, that's why we need to take measures to reduce it. This is the Green Infrastructure Facility at Newcastle University Science Campus, where they're actually experimenting with putting rock dust into the soils for mineralization, as well as looking to capturing carbon through vegetation. But first of all, you need some soil, and we're seeing too much development up and down the country that looks like this, which is completely sealed over, and you get a tiny little trench of soil and some plants really struggling to grow. We have to avoid that at the planning stage. Here's another example. You've got a combination of a very, very well executed urban square in Sunderland, and then in Newcastle, a much greener urban square in the science campus of Newcastle University, which is combined with SUDS. And this has to be the way forward, looking at a more complete way of designing urban spaces. These examples in Germany just show that you really can green the road up, but you need to make space for it. If that was in Britain, we'd have to have a 2-meter pavement on each side of the road, so there's no space for any greening. So we need to change how we think about things, and we also need to look at how we can use drainage, urban drainage, as a way of promoting urban soils and improving the greening of cities. These are examples in Portland in the USA, which are incredibly lush, but they've made space for drainage and made space for soils at the same time. And here's a contrast. We see so often in development in Britain the use of storm lagoons, often coloured blue on master plan drawings, but they're rarely blue. They're mostly grey, or mostly brown and a bit scraggy, and often, like this one, mown to within an inch of their lives. An example from the other side of the world in New Zealand, in Hobsonville, is planted with native emergent and woodland vegetation, which completely changes how this works and gives an opportunity for the soils to start to thrive after they've been disturbed. This is just a sketch we did a few years ago for a bioswale in the Millennium Village in Greenwich. We showed that we can also, the way you design a swale doesn't have to be smooth edges. We can actually start to prime niches for greater biodiversity and try and get things moving in that way. And I think that this is really coming from how brown roofs and living roofs are being designed with micro topography. So it's a way of just thinking differently. The project we're involved in New Zealand in an early stage was looking at how do you develop land for 5,000 new homes. Well, first of all, we thought, well, we need to have a water-wise approach. We call that the blue sponge. The carbon sponge, how do we look at soils, vegetation, mineralization, and the green sponge, which is regenerating local vegetation. And the way we looked at local vegetation, the native bush there will have microbial activity that may extend up to 50 meters from the canopy edge of well-established or ancient vegetation. And so here, what we showed was a 50-meter zone where we could grow that existing vegetation to make it more resilient and try and trim down where the potential urban area was going to go. So it's just trying to make more space for that. It was the same thing in Rwanda, where they'd already started to clear a rather regimented way of doing sort of American style suburbia, and working with light earth designs. We looked at trying to create a park at the center of this thing that actually was a place for a lot of this soil to actually stay and be kept active using terracing, retaining the terraced earth with vetiver grass, which has very, very long roots, to actually hold it in place, and to keep some agricultural activity even within the urban realm, because it's a very hilly area, and trying not to get this soil ending up in the rivers and silting up and causing flooding down there, and problems with wetlands. But there's an alternative strategy. This is one we looked at a long time ago now for Ebbsfleet. That came to a rather abrupt close with the banking crisis. We were saying, well, why can't we grow some of our soils and some of our future greening spaces with the idea of having legacy areas as the areas start to be developed. And we looked into how you might use certain crops like trichostin, a type of wheat which grows on very, very thin soil, so we can just get some material into it to start to break up the surface of this former chalk pit. Reclaiming soils, I mean, we all do it, and this was again about 20 years ago, looking at a hospital site in Manchester, where we looked at the larger areas that might be able to be used to reclaim soil. These were supporting shrub planting and grass. The problem is that once it goes past this stage, value engineering often knocks this out because it's rather pernickety and difficult to actually get the soil up. A lot of this is surrounded by curbs. So there is an issue there, and until soil is valued more completely, we have a problem in trying to maximize this. A lot of this would go in muck away, and that would be a complete waste. We also need to prevent soil loss from site, and these pictures here show use of straw and geomembranes to prevent soil leaking from site and silting up spaces. And we use this idea for a project to try and save soil from entering streams on a site in Colchester. It was a light impact design where it was mostly going to be green. It's now been built out, but the whole idea was to try and minimize paving over surfaces and try and keep as much as porous and green as possible. The same idea was being used for one of the projects for Kevin McLeod's housing development called HAB Housing. This was in Stroud, where it was a former small cottage hospital. The HCA had closed down the whole site for a long time, and there had been some allotments on part of the site, which you can see, which is still green over there. And we felt that while it was possible to put housing on the whole site, we shouldn't. We should actually keep as much of the soil there as possible. So we planned to keep a third of the site for allotments. The bit of allotment where we had to fit in some housing to make the thing work, the soil was stripped there but reused in the gardens. An issue there was that there wasn't enough soil for all the gardens. And I think Habit perhaps rather rashly said that everyone's going to have fantastic soil. They brought in manufactured soil, which people thought that looked much nicer than the real soil for the site. And there was a little bit of an issue about that at the time. But the key thing is, if you're developing, try not to do any more harm than necessary. And when we came to planting trees in the streets, rather than putting them in tiny little tree pits, as we saw earlier today, we looked at bigger tree pits and try and cluster trees with other plantings as well, and link those with the porous parking surfaces for the cars. Unfortunately, these developments always need parking, but if we can link porous areas with tree pits, we're starting to get the things linking up, which I think is important.
Last minute, Luke. Thank you.
Just finishing. Okay,
yeah.
Retrofitting. This is Paris. It had been wall-to-wall tarmac with trees and pits. They've just started to get some vegetation in there, or where they put their new tram in, trying to get some soils happening in there. This is just a way that trying to loosen up those hard areas to get access for routes, or depaving car parks indeed, or creating suds parks, so that we're not just dealing with water, but we're trying to create more biodiverse soils in towns. So what I'm really saying is, to get something happening more ecologically on site, you've got to think about it at the very beginning in terms of thinking about regenerative and restorative design, and starting with the idea of biodiversity that functions for the scheme, thinking about cumulative effect of actions, and this idea of sustainable retreat, because it's too late for sustainable development, and not forgetting that we're very much part of nature. Thank you very much.
Thank you, Luke. Perfect, and so much to take in there. I like the comment: soils evolve slowly, but it is destroyed quickly. That's always worth remembering and thinking about. And the slide with the 3 sponges for planning, very, very thoughtful, and something that we should all be thinking about at the start of planting schemes. So thank you very much, Luke. I think now we can start a discussion. I'm sure there are lots of questions from our 4 speakers, and our 4 speakers are here to answer any questions or we get any discussion going. So is there anyone that would like to start? Or Sue, and Emma, do you see anything there?
So should I start working backwards? So I'm looking at my big screen so I can see the things. So just working backwards, Owen Holland, is he here? He made a point about climate change and the metabolism of soils. And I wondered if he wanted to express that, or if I just read it off. I'll read it off.
Yeah.
With climate change, presumably the metabolism of soils, the variety of organisms within them, will speed up. Therefore, is it correct to assume the rate of soil's carbon absorption will increase significantly? More carbon being absorbed into the soil would mean soil volume will technically increase at a faster rate. He thinks there might be a more complicated answer to that, but
would anyone like to answer that?
From what I can see, I think it is a complicated answer, and I'm not a scientist, so I'm still trying to read up and research results from it. But what crossed my mind, that if it's linked to heating up, if we can reduce the heating, then presumably we might be doing some benefit. I think also it depends how you look after the soils as well. So I as a designer, I would like to know more about that, and if anyone can offer some advice, I'd be very interested to hear it. But these are areas that we really need to understand far better, and that research was quite recent. There was one from Boston that actually found that suburban, that was, I got the note here somewhere. It was a university study in Boston that found that the suburban areas were emitting a significant amount of carbon. But we need to understand more about long-term and short-term pools of carbon in soils. So there is a more complicated thing happening in there, for sure.
Thank you, Luke.
Yeah, maybe to add to that, from the discussions we had as part of preparing our report, it is very complex, and but yeah, as Luke says, good soil care and actually making sure there is organic matter in the soil, and also I guess the biochar, putting more biochar in stores carbon. It is then the question if it then decomposes more quickly and is back released. But yeah, a very difficult subject to tackle. And I'm not a scientist, but I think increasing carbon in your soils is always good. Yeah, but any means you can do that, really, keeping the existing soils, but also adding things, composting, adding more compost. And I did post a link to the Recon project, which is looking at manufacturing soils and enhancing the organic content.
Professor Manning in Newcastle, he's at the geology department, has been pioneering this research about mineralization of soils, but also using crushed concrete, which we often use crushed concrete on brownfield sites for the makeup underneath roads, but unless it's exposed to the air, it's not going to do the mineralization. he found, astoundingly, that where the old Scottish and Newcastle brewery had been demolished, and that's where the new science campus has been built, he measured that the crushed concrete there was absorbing between 80 and 86 tons of carbon dioxide a year through mineralization, which far exceeds rates of forestry, which is about 2 to 4 for broadleaf and about 4 to 8 for softwoods. So it's a what he's done in the GI facility looks like they put in crushed rock in there to do some of that work, and I wonder whether looking at that as part of the mix, notwithstanding the transportation needs, but whether that's part of the way that urban soils can tackle some of or offset some of the problems that might be happening from warmer climate, as well as using the trees themselves to try and cool down the city. But the thing is, to do that, you need a significant amount more planting. I think that's what TDAG's all about, isn't it?
Right.
Thank you. Just on that, can we over egg organic matter? Can we put too much organic matter into soil for trees?
Yes, you can. I mean, ideally, you should be aiming between 3 and 5%. And I kind of just alluded to it a little bit when I put up one soil sample. When the organic matter was over 20%, that means 1/5 of the soil. But the main issue with that is it wasn't breaking down because of the compaction and lack of biological activity. You referred to the nitrogen cycle, Tony, and you are right. If you've got a huge amount of organic matter and then all of a sudden it starts to break down, if we alleviate the compaction, then you're going to hit that ammonium stage of the nitrogen cycle, and that's going to burn the roots. So you can over apply organic matter. Yes. Yeah.
Okay.
I guess one thing, my thought on this is also that if you want to get your trees to get trees growing well, it's essential, because the better they grow, the bigger they are, the more carbon they store by just making that wood and making the roots. So if you have poor soil and your trees are still the same size after 5 or 10 years, they're not actually doing anything. So to get that right, the balance of good soils, good organic content, but not too much, no compaction, suitable rooting environment, and the trees growing well, then that's ideal. And I know in Cornwall, our team here in Cornwall Council that is looking at microforests, and they, for example, found that you really need to work hard with your soils to make these microforests the best they can be, and so emphasizing the growth aspects and getting the trees to grow, and being also in the place where they are to grow for the next 100 years. I think that's equally important to that discussion.
Thank you, Birgit. Sue, you've got your hand up.
Yeah, I had, because just looking at the various comments and things that have come in, there seem like there are 3 areas. One is sort of all sorts of policy things. You know, we've had the 25-year environment plan, all that ambition. And Paul Casey made a good point that, you know, we don't enforce planning conditions. Somebody else said we don't have the resources to do it. So it seems like that whole policy side. Then the other thing that seemed to come through was contractors and developers understanding what their responsibilities are and what they need to do. Do we need to consider better training there, particularly for contractors on site? And then the other set of things was on all the physical aspects of soils and their impact on life. So it seemed like there was three sort of things that we've got to somehow make all work together.
Yeah.
Tony, I just wondered if Aileen had anything to say. Aileen, if you don't, I'm sorry for putting you on the spot, but I wonder if you could fly the flag for by 4.
In terms of the soil carbon storage, you mean? Yeah. So I think, I mean, kind of the end bit of that question kind of hit the nail on the head with the, is it more complicated than that? And I think, yes, as it's come across, it is very complicated. I think one of the things that haven't been said already is that I kind of alluded to it a bit with this balance between storage with your mycorrhizal fungi and the actual biomass that's within, or the carbon that's stored as the fungal biomass, and then also how much is being released by decomposer fungi. And one of the things that we might be looking at with climate change is a shift in the type of fungi that we're seeing associated with trees and different species, and the amount of carbon they can store is different. And so, you know, we are lacking in this kind of understanding of how climate change is going to affect the carbon balance in our soils. And yeah, that is where I can fly the little BIFOR flag and say that that's something that hopefully, or it's being researched anyway within the BIFOR experiment, looking at how climate change might affect these carbon cycles. And it's not just at BIFOR, it's elsewhere as well. But yeah, big question, complicated answer. So yeah, it's not an easy one, unfortunately.
They never are easy, Eileen. So thank you. Sue, are there any other questions? One comment that I did see come in was could use of trichoderma in soils be detrimental to the other fungi? So I'm going to put you on the spot again, Aileen. You know, trichoderma is one of those mycorrhizal fungi that we're all looking at for the cure to honey fungus, or to be able to grow trees where we have high honey fungus outbreaks. Do you think that's something we should be worried about?
I think in general, at the moment at least, because of the lack of understanding we have of fungi in soils and in the kind of system in general, I'm quite cautious of introducing new fungi in, you know, massive quantities into the system. So we kind of touched on it a bit earlier with, you know, using these mycorrhizal mixes and putting them into the soil to try and improve tree growth. I think generally the products that you get are very under-researched and quite often completely the wrong fungi for the system. So, you know, the mixes that you buy are stuff, you know, they're not UK species, they're from, you know, the US or other places. They're not the species that you would find that would actually associate with most of the trees that we're looking to plant here in the UK. And in terms of honey fungus specifically, obviously there are places where there are issues with honey fungus, but I think generally as a problem, I think it is perhaps people are maybe over concerned with it, and maybe this is me looking at it from a fungal ecologist perspective where I'm thinking all fungi are great. I get that honey fungus can be an issue, but I think sometimes it's okay, we lose some trees to honey fungus, we leave them, and you know, it's part of the system. We need deadwood and decaying and dying trees. That's part of the ecology of the system. And so I would be wary about introducing new things where we don't have more knowledge. I think it's good to have testers and trials and experiments, but on a wider scale, I wouldn't be wanting to introduce it without having more small scale tests, basically.
Yeah, maybe Tony, if I could just pick up on that as well. One of the things, because I do have a pathology background, is not many people realize is that for these types of fungi to kind of keep their, what we call their virulence, their strength, they need to go through a living host. So for example, if you subculture, let's just say honey fungus, and you keep it on culture for too long, there's no way it will infect a tree. It loses its virulence. And what Aileen's just said about a lot of these trichodermas, I agree with in total. I mean, like we say, a mug of soil has like 6 to 8 billion different living organisms in there, and we just throw in the trichoderma and we just hope. And I used to do a lot of research with a guy who's sadly no longer with us, Roland Fox, who wrote 3 or 4 books on honey fungus. And he always used to recommend like spent mushroom compost because it's inherently high in trichoderma and it's a waste product. And he always felt that kind of had a niche again, rather than going to these commercial products where we really don't know their provenance, where the claims manufacturers make are extravagant, supported by very limited independent research. And as I often say, a lot of these commercial products, you buy them in sealed plastic bags, and very few living organisms can survive long in a sealed plastic bag.
So just sticking with the fungus for a minute, Tony.
Yes.
Natasha asks, is there any data on fungi in agroforestry systems, thinking about potential risk to agricultural crops and or tropical forests? And Steve Gray says, how does glyphosate spraying of trees affect fungi? And those, I think, are our last fungi questions.
Right.
I mean,
Glenn.
in terms of,
Oh, sorry, Aileen, yeah.
yeah, in terms of glyphosate, I don't know. I don't know if there's any research on that. Maybe somebody else can come in on that afterwards. And then in terms of the agroforestry systems, again, there's very little research as far as I know in terms of fungi. So when you've got agroforestry or like wood pasture systems, where you've got, you know, really low density numbers of trees, of how you get the interactions between the typically ectomycorrhizal fungi that are associated with the trees, and then the arbuscular mycorrhizae that you get with the crops or grasses, that sort of thing. What I would say generally is that the vast majority of fungi are not disease causing and are not pathogens. And so most likely what would happen is you just have more different, you know, higher diversity of fungi in the soil. It's very unlikely that you would have diseases being spread between trees, crops. And I think that's, you know, I wouldn't be concerned about that within an agroforestry system. I think you just get a more diverse range of habitats, which I think in the vast majority of times is going to be a good thing.
Thank you, Aileen. Glenn, did you want to?
Yeah, I mean, I have read, I wouldn't say I'm an expert, but I've read a few papers on the impact of glyphosate on soils and in terms of how it kind of influences, you know, kind of like the rhizosphere, etc. And the general consensus is it's more negative than positive. It really, I mean, it is a synthetic chemical. And what people fail, you know, well, one of the things is we use the word glyphosate, and the manufacturers are very, very clever when it comes to the wording. And what they say is that, you know, glyphosate is broken down within 10 minutes of applying to the soils, and therefore it's pet safe. And they're 100% right. Glyphosate is broken down, but what it's broken down into is a compound we refer to as AMPA. Now that sits around for about 6 to 8 weeks, if not longer, and that is just as toxic to plants as glyphosate. So, and in fact, whenever we do any herbicide analysis, because I get involved in a lot of, sadly, legal cases with malicious poisoning of trees, we rarely analyze for glyphosate because we know it's broken down so quickly, but it's broken down into AMPA, and that hangs around a long time. And that is really detrimental to, as I say, the soil flora and fauna.
Thank you, Glenn. Sue, what's the other thread of, we're finished on, I think we might have finished on fungi for now.
I think we've done the fungi. So one thing that's come up, actually, Glenn's just started to touch on it. I don't know if Hen Abbott's actually on, you know, is she here? Are you there, Hen?
I see, I'm here.
Oh, great. Your question about, you know, street trees and actually how to do some tests would be a really good one to bring up at this point, I think.
Yeah, can you read it out, Sue? Because I can't remember the exact wording.
Yeah, okay. Thinking about street trees on new developments, can the panel suggest some soil tests we can request developers to undertake so we can understand the base soil before deciding the best tree species and planting method?
I mean, again, there's a new soil test that has been developed by it is a company called National Resource Management. It's where I send my soils to. And they've got this great new, and what it analyzes is pretty much the macronutrients, the micronutrients, the pH, and biological activity. They subject the soil to a, they measure basically the amount of carbon dioxide it produces, of what we call a respiratory burst. And obviously anything that's living is respiring, and the greater the respiratory burst is, you know, the more healthier the soil from a biological concept, that's all. So I think there are these techniques that are available, but obviously you have to pay for them, that's all. And they can come in at, they're not cheap. They might be something like about 80 pounds a pop, that's all, but they do exist.
Yeah, thanks. I mean, I'm a highways engineer and we do a lot of development management. So we follow applications through planning and master planning. There was a lot of comments on the chat about master planning and planning enforcement and planning decisions and things. And we don't have the expertise in that entire system. We rely very much on the landscape architects which is one very, very small part of a planning design and planning application. And landscape architects, they advise their client that that's all they're paid to do. They can't really lead on anything. They can't decide on stuff. And we get 2 metre verges, 1.5 metre verges, carriageway one side, footway the other, impermeable, hard constructed areas. And we're supposed to put these linear trees in this verge. So the whole soils thing, how do we know what's the right soil? I mean, we could take all that soil out and put new soil in. In fact, a lot of the time they do, because most of that soil gets dug out during the construction process anyway. But also the rhizome issue with connecting trees, I'm wondering, should we be adding additional soil, different soil, just to make sure that those linear trees connect? Because we don't have forests, we don't have patches, we have one tree, and then we have a street light, and then we have something else, and then we have another tree. And it's kind of, is there a simple way that we can look at what the existing soil is and say, oh, okay, you've got X, Y, Z, you're missing A, B, C, you need to add this, and this is a good tree to put in there?
Well, I could come in on that if you like, or I don't know. I think I almost take a step back. I don't think it's so much about testing exactly what nutrients you have in your soil. This is almost a secondary question. And also, I think unless you got very specific soils, like very whatever lime pavement, lime soils, and very heavy clay soils, I think a lot of trees will grow in a lot of the soils in between. So the species is not necessarily, in my mind, that key concern in terms of soils. What is much more important, I would say, is that you get the drainage right, the structure, the context, and the texture of these soils, that they are actually sufficiently permeable for roots, they've got the right pores, etc. And if you're talking about the scenario of a 2 meter strip between a pavement and the road, you can be very certain that this will have been trafficked and crossed by a lot of construction machinery. So your existing soils will almost be non-existent. There might be a subsoil layer somewhere underneath, but that isn't your growing medium for the trees. So you are looking at re-importing your trees and doing that and re-importing your soil and putting the right soil in there. And for trees, for soils that are supporting tree planting, tree growth, you need to look at the right texture, structure, and organic content. And then I think you don't have to worry about the exact nutrients that much.
Thank you.
Thank you, Birgit. Sue.
So Tony, there was just one more question that I saw. I mean, there's other things. I will circulate the track and people can look at them and answer them. But Daisy came in because we're all very biodiversity net gain kind of fixated at the moment. So her question was stripping topsoil to either, how would you calculate or factor that in our biodiversity net gain calculations?
Cool. Luke. I'm looking at Luke Engelbach from Engelbach Studios, who must have an answer to this.
I don't have an answer to it, but I've thought the same thing. There has to be something crazy, with, I don't know what the percentage is in the UK in terms of biodiversity of the soil, but we know that worldwide it's somewhere around a quarter of all biodiversity in the soil, and I don't think it's being picked up. I mean, it's certainly back in the days of BREEAM, we're thinking, oh, if we could pick up things like mosses and things, we can show that there's more biodiversity. But I think it's something that needs to be really teased out for the biodiversity net gain.
Sue's going to help you out, Luke.
It gets worse because Robert Wilkins says, well, you don't bother because soil's excluded, but then that seems like there's as you just described, a huge area where, damn it, we should be including it.
Well, I totally agree with you. This is the problem of these sorts of things. They're never that good. They never capture the whole thing.
Yeah. So that's all I've found, Tony, unless anybody wants to rapidly put their hand up and say you've really missed a very major point that you should have picked up.
Yeah, I can't see any hands up on my screen. But I'm not going to let the speakers off that easy, Sue. So to conclude, I'm going to give a scenario. I've got a chalk arable field that's grown barley for probably 20, 30 years. It's now been given over to planting trees, a small arboretum. If you were planting trees into that soil this weekend, what would be your main, not concern, but what if you had to add something or take something out, or a soil improver? For each of our speakers today, what would the key thing be to you to enable successful tree planting? I'm going to start with Aileen.
On the spot. I think, well, I would want to know whether there's any other existing woodland nearby or not.
Yes, there is.
There is. Okay.
Yeah.
In which case, I think I'd want to maximise the benefits that you've got from that existing woodland. So I'd be choosing species that match with that existing woodland. If it's close enough that that's a seed source, then I think you can.
The problem is they're all ash.
They're all ash. Okay.
Yeah, I'm not going to make it easy for you, Aileen. Yeah.
I mean, I still think there's going to be, if it's an existing woodland and it's been there for some time, there's still going to be lots of benefits to that soil and maintaining some sort of continuity with that existing woodland, even if it is ash. And it's not like you'd be clear felling that ash anyway. The ash is, we want to leave it be and see how much of it survives. And so I think it would be trying to pick species and try and get some sort of continuity and joining up what would be our new woodland with this existing woodland, so we can try and get some of the microorganisms from the soil and then the existing ground flora and trees and that sort of thing to make a larger woodland, and that benefits for the existing woodland, but then also this new woodland that you're going to create.
Okay, thank you. Glyn?
I mean, if it's a chalk soil, then you've got to go looking at the pH because odds are you're going to have an alkaline soil. And if you're planting a wide diversity of species, and some of those are acid-loving, magnolia, birch, etc. And the key thing is, I mean, plants just don't magically adapt. If they're designed for an acid soil and you put them on an alkaline soil, they're just going to die. So to me, I would focus on the pH and then just match the species to the soil.
Okay, thank you, Glyn. Birgit?
Sorry, I had to unmute. Yeah, because it's chalk, it's a specialist soil, which I guess down in Cornwall we don't have that sort of thing. So I agree with the pH side of things. I would also then say, well, would there have been chalk grassland, which is very rare. So do you even want to plant trees? What are your constraints around this? And I guess that's where the argument comes in of weighing up the various different land uses and constraints. So is that actually an appropriate tree planting site? And yeah, other than that, you would just, if it does turn out to be an appropriate tree planting site and you found species that will tolerate the pH, then you go and plant them accordingly, or you consider natural regeneration, which equally would be beneficial.
Thank you. And finally, Luke.
Well, as it happens, in my youth, I did my year out down in Chichester on the countryside team. And this is a long time ago, we got involved in a lot of tree planting, including going up ourselves to plant trees on the top of the downs. For, I think it was the Queen Mother's Clump and the WI's Clump and Faith, Hope and Charity, and all this along between Brighton and Petersfield. And back then, I remember that the two things were happening. We were still seeing some areas of woodland being taken away and being turned into barley fields. But where the species that seemed to survive best started off with the scrubby ones like hawthorn and blackthorn to begin with, and some field maple in there, so the smaller stuff, some white beam getting in there, and viburnum, those sort of things that you would see on the downs. And we were also on Faith, Hope and Charity, we were planting beech. Now the problem with climate change is that beech hangers and beech stands are likely to have a real problem because they're so shallow rooted, and we're worried about the soil. But at the time we were planting beech, and there are famous beech hangers on the downs. So I wonder whether one might be able to try those to see if they will still hang on in there. But certainly the smaller stuff definitely worked and grew up. And then depending on where it was on the downs, that because it was small leaf lime was still native there, it's not particularly good on chalk. But I think there's a certain amount of experimentation with things that might or might not grow. So perhaps I need to go back and see what's still alive. We used to reckon about 10% of them would die because of a bit of drought and stuff, and they were just notch planted into the ground.
Great, thank you, Luke. Sue and Emma, you're both happy. We've come to the end of the questions and discussion, and so that leaves me to first of all thank our 4 speakers today, who have covered an incredible subject, and quite a wide, diverse subject it is, and I think most of it's been dealt with really well. So thank you to the 4 speakers, and I'm sure it's whet the appetite for people to learn more about soil and go away and think about soil more, and not just bury our head in the sands and hope that everything's okay. So thank you very much. And I'd like to thank TDAG for putting this seminar on and thinking of this subject. It seemed quite a long time ago since we first started talking about it, and it's come around so quickly. And actually it's gone so quickly, 2 hours. Amazing what you can do in 2 hours and how much soil you can shift in 2 hours. So thank you, Sue and Emma, for organising today and for bringing together quite well. It just shows how important soil is. We had almost 200 people in the seminar today, so that's a real accolade to TDAG, the Arb Association, and everyone else. So thank you very much, and enjoy Christmas.
And Tony, thank you very much for chairing it so well and driving it along.
You're
I
welcome.
think that's so claps all round. And obviously first steps in soil, probably need to take a few more before we've got our heads around it properly.
Watch this space. Watch this landfill. Yeah.
Okay.
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 Lovely.
Thanks, everybody.
Thank you, everyone.
Bye-bye.
Bye.
Thanks, folks. Take care.